Okay, today we start with another interesting concept which is connected to our critical concepts of area, that is about triangles. We saw yesterday that unit square can cut itself into half into triangles, yeah, and then triangle's area is half of the unit square it is part of. But the triangle has very interesting properties. We were playing with the children on triangles, play, everything starts with play. And I said, okay, we have 3 dots anywhere. And if you join them, what will it make? It's a triangle. Okay, if I move it a little bit, they will still make a triangle. Yeah, they will still make a triangle. Is there any chance they will not make a triangle? No, uncle, that's not possible. They will always make a triangle. And then I did this. Oh yeah, that can't make a triangle. So what does it mean? Oh, they will not make a triangle if they are on the same line. Now imagine they had put it into the road, something like non-collinear 3 points will make a triangle, but they absolutely have no idea what they are talking about. So that resonates in my mind. Knowing the name of something and knowing something, as Richard Feynman said, is totally 2 different ideas. So play with them, ask them this thing. And then I said, okay, you're right, good, interesting. I have some sticks, and can you make triangles with them? Yeah, we can. And they can start making triangles, and they can make endless types of triangles with them, yeah, right? My question was, will they always make a triangle? If I give you 3 sticks, will they always make a triangle? Yeah, uncle, why not? They will always make a triangle. Fine. I give you sticks. Make a triangle. And then started doing it. Oh, no, they don't. So, we must teach the limits where things start working, and there are certain things beyond which the things don't work, right? We just tell them the fundamentals and just run away. We tell them how to write and don't reach the calligraphy, right? We should. So that was another learning point for them. Again, the triangle, know the name, don't know the properties. Okay, unless these 2, at least if they become equal, what will happen? No, it is still not a triangle. We have a different name for that. Let's say a degenerate triangle. Everything can degenerate into something. A line can degenerate. That we'll talk later, but fundamentals. So they said the put together have to be a little bit more than that, and it will make a triangle. Understood it because they were playing with it. So we learnt another property, that if a triangle is ABC, sort of the sum of 2 should be a little bigger than the other one. Imagine, they know the triangle, but they don't know the properties. Next, we said, I have a shape. Let me make a shape. Your house looks like, for example. What shape that you have studied, triangle, quadrilateral, hexagon, pentagon, you can have ties which can fill this shape, right? You said, yeah, most of the time we need different, we need square ties here, we need, 1 square, 1 rectangle, 1. They didn't know the property. I'm telling you, 16 years I studied education in this system. They didn't tell me that triangle can actually fill in everything. Triangle, if I have a triangle, any shape, I can fill in with triangles, right? 6 triangles will fill it. Any shape, it will fill in by triangles. I have this shape, I can cut it into triangles. Very interesting. Triangle can tessellate. That means triangle is the basic cell or atom or building block in the flat shapes, or we would call them 2D shapes. Was never kind of told in that sense in the schools. Interesting property. I mean, if I want to tile something, eventually at the corners I have to deal with some triangles, right? And that's why how we broke a circle into triangles as well. One of those triangles is a little more easier and interesting, and that was this triangle, something which has a right angle or straight angle sort of triangle, because it's easy for me to find the area. It has a very interesting property. If I cut it here, I get this similar kind of a triangle. I cut it here. The smaller triangle is a similar child of the bigger one. The ratio I find over here and here is the same ratio I find here and here. This is a tremendous property of the right angle triangle, which is the first strong binoculars human beings invented is this. Using this, we can measure distances where physically we can't reach, whether it is the sun or it is something across the river, or if it is height of the pyramid. I can make a part of that on my paper, and I can measure this and this. So since I can't fly, but I can walk, so I know this is let's say 10 kilometers, and I don't know what's the height of this. I don't know this, but the small triangle is maintaining the same ratio. So I have measured it. Okay, this was 10 centimeters, and this came to a 0.5 centimeter, let's say. So if it is 10 kilometer, this will be 0.5 kilometers. So I guessed. That's how probably Thales did it. And Al-Biruni, sitting on the Salt Range in Pakistan, present-day Pakistan, using at the top of a mountain, he saw a flat land in front of him over the mountain and drew a triangle which was likewise similar to this triangle, and calculated the circumference of the earth, which is still correct to 5 decimal places. Al-Biruni, imagine how many years ago he came with Mahmud Ghaznavi, years back, centuries back. So try, and interesting use is marvelous. This property is marvelous in the sense that I want to measure how broad the sun is, or what's the diameter, and I use my lens, right? And I find its image over here, the image of the sun, yeah. And it's the same ratios. The ratio of this to here and ratio of this to here is same. If I somehow know the distance, it's 150 million kilometers, I can tell the diameter. That's how my binocular and microscope works. Microscope goes this way and magnifies, right? Binoculars goes this way and sort of it tries to reduce and something. Amazing, isn't it? We'll never thought about these things. We were taught, triangle, you see it has 3 angles, and the 3 angles are always 180. I have often asked children, are you sure 3 angles are 180? Don't go for the rigorous mathematical proof they are 180. But are we showing them it's 180? At least I don't recall in 16 years of my journey. Anybody has shown me in the schools triangle is 180? Simple. Make a triangle, draw angles, just color them. We are assuming they already know what is 180. Cut it from here. Alright. And let's put these angles together. Do they make a straight line? Oh yeah, they make a straight line. And do it with 3-4 triangles, and they will understand that a triangle always makes 180. Right? But this is a destructive method. You can go for a non-destructive method as well, and that is take a triangle, fold it on this side and put it into half, fold it on this side and put it into half, and from these 2 half points just fold it down, right? You will get a shape where this can bend symmetrically like this, and this will bend symmetrically like this. And every triangle will let you do that, right? Now that was very amazing. When we did it, the children found out that every triangle can be folded into a rectangle. At least I didn't know about it, that every triangle can be folded into a very interesting rectangle. That means the area of this rectangle is half of the area of this triangle. Amazing, isn't it? mathematical proof and algebraic proof will come later, but at least knowing the thing itself and playing with it connects to a huge lot of things. And I know the triangle is 180, but if triangle can cut anything, that means of any 2D shapes, particularly these, for example, the regular polygons, it has 3 triangles, so that means the internal angle altogether will be 180 times 3. If it is 2, the internal angles will be 180 times 2. This is 103. So if I go for the 6, so obviously I can make 1, 2. Oh, this is 6 already. If I go for 5, I can make 1, 2, 3. 1, 2, 3, 4. This is 4. Right, sorry. And this is 4. This is 180 times 3. So I note down it has a 5 shape, 6 sides, but it's 4 triangles appearing into it on the side such that no angle overlaps. 4 sides, 2 triangles. 5 sides, 3 triangles. Oh, if it is n sides, it is actually n minus 2 triangles. Children discover it in less than 10 minutes. Just by patterns. We learn by patterns. So that was another interesting property, but that's a use within maths itself. Let's go a little beyond. And little beyond it, have you heard of Sagarmatha? Sagarmatha? What is Sagarmatha? Or Chomolungma? Sagarmatha, Chomolungma. We don't know, and we did not know. These are the local names. Sagar means sky, Matha means forehead, the forehead of the sky. These were names of the Mount Everest. Right? When the George Everest, in the great triangulation of India project, probably in the 19th century, this was the biggest project in terms of resources, in terms of outlay of budgets. He established something in 1850s, the height of this, which was something like 29,029 or something. 31,000 we are flying, a jet is cruising, just a little bit below it. George Everest. We have named it on, remember your heroes, remember those people. Mount Everest is called Everest because it was, with the help of triangles, we measured the height of that. You know, still the universe is expanding. It's continuously expanding, right? The rate of its expansion, that's the only thing we know about, is faster than the speed of light, right? Apart from this fact. But is universe flat or universe is curved? A simple triangle can give the answer to it. How? If we are flat, our triangle is always 180. But if we are not flat and try to make a triangle on a spherical thing, right, say bulging outwards, the triangle will always be more than 180 because the angles are, take the Rollo triangle. Its angles, since a little curving outwards it's more than 180. So if the surface is not flat, the triangle will give us 180 plus sum of angles. This fact scientists are still using, taking the furthest 3 points and measuring the angle, but they're still getting 180 plus 0, 0, 0, 0, 0, 0, 0. At no point in we are getting any figure. So still in our observations, a triangle is telling us that the universe is flat. Intuitively we know the universe may be curved. Means what? We are so tiny, we have treaded so little that we haven't yet discerned that curve. If it's a curve and I look at a very little part of it, it looks me flat, like an elephant. If an ant is moving on the elephant, it will think, or if an ant is moving in a football ground, it will look like a... So that's strong and interesting. And have you seen the football grounds and airports around you and all those big structures, or big structures like bridges? You will always find these trusses like this, big poles. You will always find this triangle. Geodesic structures we call them. They're all made by triangle. Why? Why triangle is so interesting for construction? Why we make this our small bicycle as a sort of triangle? Reason, triangle is an interesting property. You see, this is a rectangle, and I can, even if the sides are fixed, it can move. So it's flexible. It's not rigid, right? But if I have a triangle, and if I can fix it over here, no, it will not let me do anything. It's a rigid structure. So this is another interesting property which is marvelous, which helps us make structures. Point to say is that we must start seeing the miracles inside everything. That's the lesson. And we must start questioning everything. Why not we leave you with a question? It's a triangle. But if I put this thing, you will call a pentagon. If I put this thing, you generally call it, or this thing, you call, these are quadrilaterals. These are quadrilaterals. This is a pentagon. Do ask your teacher this question. Why not this is a trigon? Or why not it's a trilateral? If this is a quadrilateral, it should be trilateral. If it's a pentagon, it should be trigon. Keep asking questions and look at the fundamentals. Thank you very much.